Okay, so imagine that we are in a, between quotation marks, in a good scenario, in a good stand, in the sense that we found evidence to our hypothesis, and we were able to correctly reject the null hypothesis. What can we expect next? And this is the question that Pollock and Edwards told us to think or to have in mind in scientific research. The next step is the what else questions. What else can explain my dependent variable or my outcome variable? Because as Pollock also says, for every explanation we propose and for every hypothesis we test, there are alternative causes or rivals explanations for this phenomenon, right? And reality is very complex. So for anything we want to explain, there are probably many different factors that can also affect that phenomenon, right? Again, how can we tackle that complexity? We need to embrace that complexity and to some extent simplify it or make it use variables and use simple analytical tools to try to explain this complexity and also embrace that complexity. And causal assignment or causal attribution is a very hard enterprise, right? Because we need to do three things. We need to show covariation, as I explained before. We need to show that our causal factor occur before our outcome variable. So X happened before Y, otherwise it's not possible to attribute the effect, the force of X to Y as a causal factor, right? And the third thing is that we need to eliminate all other potential factors, so rival explanations explaining why. And in this case, we use the letter C to talk about those rival factors, okay? How can we convince our audience that there are no other rival factors explaining why? We need to show that the two groups under comparison were similar or equal before X happened. Because if I am able to do that, I can show that only X had an effect on Y, on the group. For instance, one of the groups that experienced X had an effect on Y, okay? Otherwise, there are compositional differences that can be the real cause of Y. Okay, I'm going to give you an example of that based on the book of Pollock and Edwards that I think can help me to explain you this concept. But the key idea is this one. If we are not able to show that the two groups under comparison were equal before the occurrence of X, we may face something that is called selection bias. Selection bias is that we included in the group that received X and the group that didn't receive X, groups that were probably different in other factors, and probably those factors can explain why. So remember that in that example, I told you that we want to know if students who attend online lectures are or perform better than students that attend traditional lectures. And we found a 2-point difference in the mean scores at the end of the experiment. But we didn't know, in favor of the traditional method. But we didn't know that the selection criterion was the GPA. Instead of a random variable, we select each of the samples based on the GPA. The students who receive the online classes were students with a lower GPA than the average of the class. And students who receive the traditional classes were students that outperform their their peers in the classroom. Because of that difference, prior difference in academic performance, we are not sure that receiving the treatment in this case the traditional or the online classes were actually what explain the results of the experiment. We may convincingly argue that it was the academic performance of these students prior to the experiment what explained the actual results of the experiment. Okay, so we have a problem here of selection bias because we put in one group students who were actually better students than the other group, and it doesn't matter if they receive different types of lectures or not, of teaching method or not. Probably the most important factor here were their academic performance before the experiment. Okay? So how can we deal with these rival factors? What we are supposed to do is to control or keep them, hold them constant, and in such a way control for these C or for these rival factors help us to see if the effect of X and Y still is present or not. Okay, and we probably, if we do that, we can probably experience three different kind of scenarios. The first one is that there is a spurious relationship between X and Y. And what happened here is that maybe C is affecting both X and Y. And it's not X what is affecting Y, but it's C what is affecting Y. So C is what we call in statistics a confounder. Okay, let's use this example of Pollock and Edwards. They say they want to explain the public opinion about gun control in the United States, and they contend that partisanship is the most important explanatory variable. And they find evidence to this in the actual data. I think is the general survey, something like that. So they found that Democrats tend to support gun control in a higher percentage than Republicans. The difference is very high. But what happened when they control by a rival factor? For instance, alternative theories can say that it's gender what actually explains gun control. And they have an explanation, an argument why women are supposed to be against the use of guns and they are supposed to be supportive of more of strict measures to control the use of gun in the United States, right? So we more than men. So we control by this, and we find this kind of evidence. We find that, in effect, it's not partisanship what explains in this example the support to gun control. Female tend to support more this kind of control than men, regardless if they are Democrat or Republican. And men tend to don't support this kind of policies. Okay, so this is an example of a spurious relationship between X and Y. So spurious means that there is no real relationship. That is something else what is causing this effect. Okay, there is a second scenario. The second scenario is that both X and C explain part of the variation of Y. This is called the additive relationship. Additive because you actually sum some of the effect of X and some of the effect of C on Y. Okay? And what happened here is that even if it is true that like a gender has an effect on Y, on gun control, the partisanship of the people in the United States can also affect their support to this kind of policy. And Democrats in general tend to be more supportive of gun control than Republicans, regardless if they are women or men. This is important. Okay? And the third type of relationship is what is called an interaction relationship. And in this interaction relationship, C mediates the effect of X on Y. Okay? And according to the presence or absence of some values of C, X has an effect on Y or not. So look at this example. For instance, for female will support gun control regardless if they are Democrat and Republican, but men will support more the control of guns if they are Democrat than Republicans. Okay? So a summary of this part, because it's kind of complex, is probably new for you. What we don't want to face is a situation of a spurious relationship in which C is the actual factor explaining Y, but also X. And it is fine if you experience an additive relationship or an interaction relationship. But the bottom line is that you need to control for C in order to know if C has an effect on Y and if the effect of X on Y holds or not. Okay? We're going to talk much more about all these ideas when we discuss how to interpret the results of a statistical test or statistical analysis. Okay? Okay, so what can we deal with these rival factors? The way to do it is to design a careful strategy to maximize causality. What we want to do is not only to design an empirical strategy or research design that allows us to find evidence to our hypothesis and reject the null hypothesis, but we also need to control for rival explanations, okay? And there are, in general terms, two types of research design: experimental research design and observational research design. Experiments are the golden standard in science. And they are the golden standard because they help us to eliminate this potential source of selection bias. Experiments are based on the idea that randomly the scholars or the researchers randomly assign the treatment variable or the causal variable to the two groups. So the two groups that are in comparison individuals for better. All participants in an experiment have equal chance to be a part of either the treatment group or the control group. The control group doesn't receive, or the X variable, the causal variable is not present there. And the treatment group is a treatment in which all the individuals receive the treatment or the causal variable, okay? And because the selection of these participants in these groups is random, all the other differences disappear. This is a kind of a statistical trick to control for all other differences in the group. So there are no compositional differences in these groups that can affect Y. And in such a way, we can focus directly on the effect of X on Y. This is amazing. We have high leverage to attribute causality in these kinds of research designs, okay? And there are two types of experiments. One is called like a laboratory experiments, and in the laboratory experiments you have high control, right? Because you control everything, even the environment of the experiment. But these kind of research designs are better suited for natural sciences than for social sciences, because no matter what, even if you don't know what kind of experiment is going to be this experiment, you know that you are in an experiment if you are a participant, and that can bring like unintended biases that can affect the results. For instance, I can be more careful about my behavior because I know that I'm going to be tested. So probably I'm going to try to be more compliant than if I were in another kind of context, in a more natural context. I can show myself more collaborative or whatever. So that can create some biases that They are very difficult to control, okay? But there are also field experiments. In the field experiment, the researchers try to recreate the natural conditions or the natural environment of the participants. And in such a way, we expect that the participants will behave in a more like a veridic way, in a more natural way. But the problem is that we have less control over the environment and over all the variables of interest, okay? There's another problem with some of the experiments, especially the laboratory experiments, because, for instance, in the United States, it's typical to use college students as participants of the experiments. And one of the problems that my experience is that that to what extent these students are representative of the whole nation, right? They are probably highly educated people, probably more liberal people, probably younger people, probably richer people than the rest of the United States, of the population in the United States. So that can create some problems of external validity. We're going to talk about it later. The observational studies, so the rest of the studies, surveys, use of data sets, qualitative methods, and so on, are plagued with these threats to causal inference, especially with selection bias. Now, it is still possible to attribute causality with these kind of methods, but we need to satisfy a stronger set of assumptions to convince our audience, the scientific community, that X causes Y, right? There are advanced techniques such as matching. Matching is with statistical methods identify pair of cases that differ only in the presence or not of the causal variable of interest, the presence of X. In such a way we control by C, or for C, I'm sorry. Another type of advanced method is what it is called quasi or natural experiments. A natural experiment is when the assignment of the causal variable occurs as if it were random because of an external shock, something that happened that nobody controls. For instance, an earthquake. There are experiments about what happened with the communities that were affected by an earthquake and those that are not affected by an earthquake, okay? If their behavior differ in several things. Or for instance, there is a very famous experiment in political science in which researcher compares local communities in two sides of the border, right? For instance, a good experiment, if you think about it, is if you compare, if you have ever traveled in the border with Mexico, some authors claim that the border is arbitrary, right? And the communities from both sides, especially the municipalities close to the border, might be kind of similar. But what explains development in the United States of the border is the national or state policies. And what explains the lack of development in some places in Mexico, in that part of the border, is the lack of presence of like a federal state or the local state, the Mexican state in that side. So some authors have used these borders that are arbitrary as to explain these the role of political institutions, and this is an interesting kind of experiment. So, but it is not a real experiment, for the reason it's quasi-experiment. Okay, there are more rudimentary techniques, and we probably gonna study many of them because they were the more traditional type of techniques used by scientists when we don't have any other method to try to control for these rival explanations. For instance, and the most basic is the control comparisons. try to bring in a linear regression, for instance, all the potential causal factors or rival explanations of why. The problem is that sometimes you have you can have 20 factors explaining, but that's sometimes the only tool that you have. Okay, the good news is that theory guides you like what to identify what kind of rival explanations you might expect to affect why, right? So the literature, when you do a literature review, you identify which are the debates about what explain my phenomenon of interest, and you should bring variables that represent the two sides or the three sides of the debate, trying to explain my dependent variable. Okay. Okay, so this is I have given you a lot of information about research design, and I hope this is useful to have fresh in mind these concepts, but also, and you will see this is like a setting the stage for what we're gonna do in the next 5 weeks, okay? And I'm gonna give you a very short summary. Okay, so when we talk about types of research design, we talk about, or specifically when we talk about research design, we're talking about an empirical strategy that we use to achieve ideally 3 things. First, to find empirical support to our hypothesis, and we do that when we are able to reject the null hypothesis and when we find strong support to the idea that X affects Y in the way that I expected, in the way that my theory expected. Okay. Second, we achieve internal validity, and we have internal validity when we are able to reject all other potential causal factors. Okay. In such a way, we are able to say that X, is the real factor explaining Y or causing Y. Okay. And the third thing is external validity, and this is related with what I explained in the first lecture, this idea of the extent to which my sample or the results based on my sample can be generalized to the rest of the population, right? Because we can have the best experiment possible, but imagine that experiment doesn't tell me anything about the rest of the population. It tells me something just about the sample. So to what extent we are really explaining what we want to explain, okay? And based on those 3 goals of scientific inquiry, so we can have a bad research design, and bad research design is when we not even find support to our hypothesis, we are not able to reject the null hypothesis, or the support is very weak, and we're going to talk a little bit more about it. So that's a bad research design. We can have a weak research design when we find support to our hypothesis, but we not control for rival factors. So if we just have that our relationship between X and Y is strong, but we don't know anything about C, potential Cs, be careful, because the conclusions that you are drawing probably might be wrong, and you can probably incur in false positives or false negatives. In this case, probably false positives. Okay. Research design is somewhat strong when you are able to provide support to the hypothesis and when you control for rival factors. But it's somewhat strong and not strong because the threat of selection bias is still present. This is very frequent in like a good observational studies. Like you control as much as you can, you are careful to show evidence that even if you control for different variables, your results still hold. And sometimes it's even legitimate when you say, okay, my results hold, but when you control for these variables, but maybe with this one, no. And I don't know yet why, but that's the case. So that's legitimate. So it's somewhat strong, your research design, okay? And your case. Your case is very strong when you provide support and you to some way you are able to provide evidence that the assignment of the treatment variable is random. Hopefully you are able to do an experiment or simulate an experiment, or you can use these quasi experiments, or you say that you use matching techniques or something like that to provide this kind of evidence, right? But it is not a perfect research design, because maybe your results are not very generalizable. So maybe you have problems to say, or the scope conditions of your research are kind of limited. That can be the case, for instance, of most experiments. But your research design is ideal if you provide a strong support to your hypothesis, you provide evidence of random assignment of the causal variable, and your results can be generalized to the rest of the population. There are very few cases of research designs like this. Sometimes some scholars use what is called survey experiments, and in these survey experiments they have the capacity of the surveys to say that what happened in this sample can be generalized to the rest of the population, because the random sampling method was correct, the stratification was correct, and so on and so forth. But also you have the advantages of an experiment, and you can say, hey, I control for all other rival factors because there was random assignment of the treatment. Okay, so this is the summary. This was a lot, but the important thing about all these concepts is that you like process all this information, and we're gonna use this information later. And the key thing is that we're gonna build upon this foundation to try to understand what can we do with descriptive statistics when we use inferential statistics, what we should have in mind. Again, assumptions, we're gonna be talking about assumptions a lot. As in the other class, please write me if you have any question about independent, dependent, and control variables, spurious, additive, and interactive relationships, selection bias and random assignment, and the role of research design to maximize causal inference. I want to give you a clue or a hint. When I make these summaries, is because these topics are the kind of things that I'm going to ask you in the quizzes. I don't want to be like a tough with you in the quizzes or something like that. Don't take me wrong. What I want is to confirm the extent to which you understood these ideas. So if you don't understand these ideas, it's kind of normal right now or completely understand these ideas is kind of normal right now because they are kind of new for you. It's like a new set of knowledge that you need to process. But try to familiarize with these ideas. If you don't understand something, ask me questions, because probably I'm gonna ask you questions about these ideas. These are the kind of concepts that I want you to understand, and that's my goal to some extent. Okay? Use the discussion board. It's fine if you want to create new discussions, but if it is something related with these topics of the lecture 1 or lecture 2, try to use the discussion boards, because sometimes the discussion boards can illuminate not only to you your questions, but also to the rest of the students. So it can be useful for everybody. And I will be more than glad to answer all the questions in the discussion board. If you want to ask me something directly to the email, it's fine. If you want office hours, or to talk to me in office hours, I am completely available. Remember that these are on Wednesday. Thank you so much for watching this video. Bye.